Hello everyone, welcome to our lecture series on ordinary differential equation. Today we are going to embark with a new chapter that is called Equation of First Degree and First Order. Before I start with this topic, I must draw a framework that what are the contents of this chapter. The content of the chapter is variable, separable. This is the first content. And then there are certain equations which can be reduced to variable separable. So that is equation reducible to variable separable. And the next topic is homogeneous equation. Homogeneous equation. Similarly, there are certain equations that can be reduced to homogeneous equation. So we will also study that equation reducible to homogeneous equation. So these are the first two broad categories, that is variable separable and homogeneous equation. Third is our exact equations and integrating factor. Now, integrating factor is of prime importance for civil services because there are in this category there are further subdivisions, like we have one by inspection method, then we have other category also. We will be taking up in detail. I am just outlining. If mdx plus ndy is equal to 0 is any homogeneous equation, then right away we can say this integrating factor is 1 by mx plus n by y. Similarly, there are other rules also that we are going to take it up. That is, if it is of the format y f1x dx plus x f2 xy dy is equal to 0, then integrating factor here is 1 by mx minus ny. So there are other rules also. We will specifically taking up when we are going to study particularly integrating factors. And then we have linear differential equation. When we are reading our linear differential equation, then there will be certain categories of equation which can be reducible to linear differential equation. And the last one in this of equation of first order and first degree is Bernoulli equations. So primarily this is the broad categorization of this chapter. Questions are asked from all of these. If I have to tell what are the focal areas these years, invariably integrating factor is one of them. Earlier they have started with variable separable also. There are certain questions which we are going to take on today's lecture, and in homogeneous equation also, linear differential equation they have also asked, and they have also asked Bernoulli equation. So all of them are important, but the most important, the heart of this chapter which is of prime importance is this one, exact equation and integrating factor. So here this is the main thing that we have to study for Indian Forest Service also and civil services also. Now I will get started with the first topic, that is called variable separable. Please make a note of this framework so that we can study one by one each topic. So in today's lecture we are going to cover variable separable and equation reducible to variable separable. So first of all, we must have the idea as to what is variable separable. So the functions f of x and say any function g of y, they are separable in such format and then they are integrable. So I will write, if any differential equation of form mxy, because function of x and y, dx plus n xy dy is equal to 0. If we can separate this, if can be written as p of x dx plus q of y dy is equal to 0, then this is said to be variable separable, and its solution is going to be, and solution is integral of p of x dx plus integral of q of y dy is equal to one arbitrary constant. So it can be written in many ways. One of the ways of writing it is to say dy by dx is equal to, say, h of x and g of y. So we can readily see that these functions can be separated very easily. So we can write it as dy by gy is equal to h of x dx. So these are separable and now they can be integrated. Suppose integral of this is capital Gy and of this one is capital h of x, plus we have to add arbitrary constant all the time. So in this one we have to make a note of the fact that add arbitrary constant on any one side. We have to make a note of this. So this is the general format of any equation. Now we are going to take some of the questions on this topic. Okay, so now we are going to take the first question of variable separable. So we can see here m of x and n of x. If we compare, here we are having m of x y is equal to e to the power x tan y, and n of x y is equal to this 1 minus e to the power x square y. So here we can see that all these functions of x and y, they can be separated with the respective derivatives, differentials. So if I do so, ex, and if I take this on this side, this become 1 by e to the power minus x and dx plus, here it is 6 square y dy divided by tan of y. So we are successful in separating x terms and y terms. Now we will integrate on both sides. So this will give us, here we have to integrate this both integrals separately. If I write 1 minus e to the power x as t, its derivative is minus of e to the power ex dx is equal to dt. So here I can write this e to the power ex dx is equal to minus of dt, and in place of 1 minus ex I will write as t. Similarly, if I write tan y is equal to u, alright, then the derivative of tan y is sec square y dy is equal to du. So here again sec square y dy is equal to du. So this becomes du by u equal to 0. Alright. Now we know the integration of dt by t is log of t. So here is a minus sign. So minus log of t plus log of u is equal to constant, say log c. Alright. Now I will place the values of t and u respectively. So t value is 1 minus e to the power x. So this becomes log of 1 minus e to the power x plus log, what is u? U is tan y is equal to log c. I can further use the log properties and write this as tan y divided by 1 minus e to the power x is equal to c. So this is my answer for this. I could also write it as tan y is equal to c times 1 minus e to the power x. So this is a basic question to understand this concept. Now I will take one question asked in civil services examination. So now we are going to take the second question on variable separable. It is asking us to find and solve this xy dy by dx is equal to under root x square minus y square minus of x square y square plus 1. And this question was asked in IAS 2005 for 12 marks. Before I start solving this question, I must tell you there was a printing mistake in the examination itself, and here in plus, here it was minus. So what is the mistake over here? That this cannot be variably separated, and secondly, so it may come in the complex conjugate. So there is a rectification. Here it is plus sign. So now we are going to solve this. So we will write this as equation xy is equal to dy by dx is equal to, if we can club this and this, that becomes x square into 1 minus of y square. And similarly, if I write 1 here as 1 and this minus y square the same, so I am successful in separating it and bringing it outside. So this becomes xy dy by dx is equal to under root of x square plus 1 into 1 minus y square. Now I can readily write this as under root of x square plus 1 into under root of 1 minus y square. So now I can bring the terms on the right and left simultaneously. If I write y dy, and if I bring it from here, from numerator to denominator on this side, I can write it like this. And if I write dx in denominator to that side, if I send it there, this becomes x square plus 1 under root by x d of x. Now this becomes separated. Now we can very easily do the integration. Now we can integrate it. Alright. Now in all differential equation, it is very important that you solve integration very well. That means you have a very good command over integration. You can very easily play with integration. Once you are in a very good position to do integration, differential equation is just a cakewalk. So now you see here, you have to integrate this function and this function. First, I will try to do with this one. If I write 1 minus y square is equal to t square, alright. So if I differentiate this, it becomes 2y dy is equal to 2t dt, alright. So I can write this as y dy here, so 2 get cancelled. What is remaining over here is, in place of y dy I can write minus of t dt, and under root of 1 minus y square is how much? T. Okay, so what can we do substitution over here? Before to that, we can see that this can be rationalized. So if I rationalize this, I can write it as x square plus 1 divided by x into x square plus 1 under root dx. Okay, so this becomes what? Tt get cancelled. So I have got one of the integral, that is t here. Okay, so this can be written as what? X by x square plus 1 under root dx plus d of x x by under root x square plus 1. Okay. Now if I again see, this becomes integral because this is the derivative of this one. So if I put again x square plus 1 is equal to say u square, then 2x dx is equal to 2u du. So here 2 get cancelled. So in place of t I can write here as under root of 1 minus y square. Similarly I can write it as how much x dx is equal to u du, and x square plus 1 is equal to u square, but here is under root, so this will again become u. So u will get cancelled and I am left with this integral. Okay, so what we get here, I will try to write it on the upper portion. So what I have got is minus of 1 minus under root is equal to, this is only integral of du, that will be u. What is u? You can write from here, x square plus 1 under root plus this integral. Now our work is to find this integral in isolation. Okay, and then we are done with this question. So we have to find this integral. There is a slight mistake over here. While copying, I put into the numerator. It was in actually denominator. So I have to find this standalone integral, that is integral of 1 by x square plus 1 dx. Here if I put x is equal to say 1 by m. So here my derivative dx is minus of 1 by m square dm. Alright, so I can write in front of in place of 1 by x as m. Alright, and in place of dx I can write it as minus of 1 by m square dm, and here 1 plus 1 by m square. So what integral do we get? We can take the minus sign outside and this become m square plus 1 whole square. So this m goes into the numerator, so this become m square into 1 by m square dm. So this one get cancelled, so we are left with minus of dm by m square plus 1 square. So this is the standard result that we can write of this integral, that is minus of log m plus 1 plus m square. So we can now plug the value of m from here. So this is our minus log 1 by x plus 1 plus 1 by x whole square under root. So we can write it as minus of log 1 plus x square under root by x. So we have got our values here. So we can write it at the appropriate place. So this becomes minus of x square plus 1 under root, and in place of this we can write it as log of 1 plus divided by x, and we have forgotten to write the constant. We can take on any side. So we can write c plus log of 1 plus under root 1 plus x square by x is equal to x square plus 1 under root plus 1 minus y square under root. So this is our answer for this one. In this question, what was being tested is that whether you are able to separate it. You can do it very easily, but then integration, you should be pro at integration.